let's start with, did anyone need or want to see 1 through 12? I'll circle them and then we'll go and view those. For 1 through 7 on that first page. Anyone need to see any of those? If you did want to see one, you can always go back. On this page, anyone need to see any of these? Or on the last page, anyone need to see any of these? Were there any questions that we wanted to go over, had a question about, or any of these that we missed? If not, everyone has a review on their desk. We're going to go through that review. I would make sure that you get all of the answers to that because you'll be able to use that later. So starting with the first one on the first page, I'm going to run through this review, so make sure you're paying attention. For the domain and range, remember we talked about that a while ago, but this is your first objective for this unit. Domain is all of your x values, range is all of your y values. So for your domain of this has arrows. So that means there are no stopping or starting points. It keeps going forever and ever in both directions. And remember, you have to kind of imagine this. This is going to go off the graph. And it's going to keep going off the graph. So there aren't any starting and stopping points. So your domain goes on forever and ever in both directions. You can write these in interval notation or set builder notation. So from negative infinity to infinity would be your interval notation. The curly brackets, that's x with the line, and then XER is your set builder notation. That's more to write, so you don't have to do it that way. Interval notation is fine. For your range, because we have arrows, this is going to keep going down, but it does have a stopping point, that ceiling. It doesn't go higher than that. So we can say it starts at negative infinity, but it stops at 0. We can say negative infinity to 0, and that would be a bracket. Small. Lowest to highest, yep. Domain is furthest left to furthest right, and then range is lowest to highest. And then we're going to start. The second one, the way this is graphed, it doesn't show the arrows, but this one did have arrows. This is going to keep going up forever. So if you want to draw those in, you can do that. For quadratics and absolute value, that is always the case. They keep going. Go ahead. Does that work?
Yes.
So maybe for this one, it's kind of like this. It keeps going out and up off the graph. So if it keeps going up and out, domain is going to be all real numbers once again. For quadratics and absolute value, that will not change. Let's see. Range will change for both. For this one, it has a starting point, that floor, but it doesn't have a ceiling because it keeps going up forever. So it would start at -2 and keep going up. That would also be a bracket, because unless it shows an open circle, you can assume it's included. For number 3, it's asking where's this graph constant. So remember, that's where your y is not moving at all. It's staying at the same place, but your x is still moving forward. So on this graph, I can see my y is staying the same here and here. On this vertical line, your y is not staying the same, but your x is. That is not a constant. So at 2 places, so we can say from negative, what's that, 5? And that's an open circle until we get to -1. And that's it's included at that point. And then again, starting at +1, and that's included. And that stops at 3. And that is also included. Questions on that so far? Understand the constant? Understand what's going on where? Sorry.
Just in all of it.
So you're looking for anywhere where it's a straight line, a horizontal line. Okay. And there are 2 places where there are horizontal lines. Here and right here. So then you have to put the interval where those are, only using your x values. So you would look at the x value starting here, which is -5, and where does it stop at -1. Here this is open, that's why this is a parenthesis. And this doesn't have an open circle, so we can assume it's closed, that's why it has a bracket. And then the same thing for this one. This starts here at 1 and ends here at 3. And they're both included.
Oh.
Number 4, we have to write this in interval notation. X is greater than 1 is going to keep going towards positive infinity, and it's going to start at 1. This does not have an equal to underneath, so that's going to be both parentheses. Come on. This line right here, this is part of the notation. So it doesn't really mean anything, it's just there. And then for number 5, writing this in set building notation, let's say this is for x, it could be for y, it doesn't matter. This starts at negative infinity and goes to 4. So this would be curly bracket x with this line. It's everything lower than 4, so this would be x is less than. This is not a bracket, so it would just be less than 4. So those are all the things from objective 1. Do you have any questions on any of those things? Once we finish going through this review, you will be able to go back and redo or finish doing the practice that went along with each objective if you feel like you need more practice on certain things. Moving on. Objective 2 was writing an equation from the transformations. So this is where you need to remember what's inside, what's outside, and what looks like what. So for number 1, it's giving us the parent function x squared. It's saying it's translated 5 units to the left. Left is an inside thing. And remember, anything inside does the opposite. So left would really be plus. Reflected over the x-axis would do this. So that's a vertical thing, something on the outside. That means you would have a negative outside of the function. When you write these, it doesn't matter if you write y equals or f of x equals, either or is fine. F of x equals, the outside thing would come first, the outside negative would come first. On the inside, we have this x plus 5, so we need parentheses. And the function itself is a quadratic, so we need it to be squared. Questions on that before we move forward? Second one is also a quadratic. The x squared tells us that. Now we have something that is translated 2 units down. Down is an outside thing. That says outside, it kind of blended in with some of the other things. Whatever is outside does exactly what you think it's going to do. So if it says down, we're going to subtract 2. Then it's reflected across the y-axis, so it's doing this. So that means that is an inside thing. So on the inside, you have a negative x. So when we put all of those together, we have f of x equals, we do have something on the outside, but this is going to go towards the back. So we can start off with our parentheses, our inside negative x. This needs to be squared. And then on the outside, minus 2. Small. X-axis is outside, but this is y-axis. The next one is an absolute value function. This is translated 12 units to the left. So that is an inside thing. And again, does the opposite, so that would be plus 12. And then we are also translating it 18 units up. Up is outside. So that would be a plus 18. So using what we're given, we have f of x equals, on the inside of the absolute value, we don't need parentheses for this one, x plus 12. And on the outside, we have plus B. Yes, Mom.
I know.
It'll say it right here. And then for this last one, we're using absolute value again. This is now being stretched. Change this to vertically. And compress. So this is being compressed vertically by a scale of 1/2. That is something that goes on the outside. And we're just going to multiply it by that 1/2. Reflected across the x-axis is an outside thing. And translated 12 units to the left is an inside thing. One of these was supposed to say right, but if it said right, it would just be minus instead of plus. So for this one, you'll have 3 different transformations you need to introduce. On the outside, we need the negative first. And then our scale factor of 1/2. Then we need our inside piece. This is an absolute value, so we don't need parentheses. But we do need x plus 12 on the inside. Questions on that one? The third objective was writing equations from a graph. So I would say list out your transformations off to the side. That will help you be able to write your equations. So for this one, if you need to, write in your parent function. It's not a necessary thing, but if it helps you see what happened to it, what changed, you can do that. So from the parent function for this one, I see that the distance between the points are still the same, so all it did was move. And it moved down 4 into the right 1. Down would be an outside thing, right would be an inside thing. This is a u, so that's going to be your x squared. So putting all of those things together, we have f of x equals, we need our inside thing, x, this would be opposite, so minus 1. And this is a quadratic, so we need it to be squared. And then our outside thing, minus 4. What questions do we have on that?
Wait, so how do you know it's x to the second power?
This is a u, so that means it's x to the second.
Oh,
If it was a v, it'd be the absolute value.
okay.
For the second one, the original would start at 0, 0, and go up 1, left 1. I'm sorry, up 1, right 1, up 1, left 1, as many times as possible. So again, this is not necessary, but if it helps you see it, you can do that. I see that this was moved down 3 and to the right 1. And it looks like it got narrower, so I'm just going to check the scale of it. Find 2 points on the line, count the slope. If it's the same, it didn't change. If it's not, it did change. But here, the scale is now 2. So it was vertically stretched by a scale of 2. This is our absolute value function. So now that we know all of those things, we can put them together in an equation. Our scale factor would need to come first. So we're multiplying it by 2. And then our right would need to go on the inside, and that would be opposite, so minus 1. And then our down 3 on the outside. Questions on that one? Objective 4 is being able to describe the transformations that you see in words. Remember, these need to be very specific, using the words translate, reflect, vertically compressed, or vertically stretched by a scale of. So for this one, there are 2 things. The plus 5, and it doesn't matter the order, the plus 5 would be a translate. It's on the outside, so that would be an up or a down. It's plus, so it would be up. The negative would be a reflect, and since it's on the inside, that is a horizontal reflection, so it reflects over the y-axis. Questions on either of those? In the second one, we have a negative, an 8, and this 13, plus 13. So this one is going to have 3 things. The negative would be a reflection. Since it's on the outside, that would be a vertical reflection or a reflection over the x-axis. The 8 on the outside, if it's bigger than 1, that's a stretch. If it's a fraction, that's a compress. So that would be a vertical stretch by a scale of 8. And then the 13 on the inside is a translation, and it's opposite. So whatever you're thinking, do the opposite. It's plus, so it's really moving to the left. So translate left 13 moves. Any questions on that one? Then the last objective we've been practicing is for a couple days now, but this is your graphing absolute value and graphing quadratics. Remember, you can have your calculator for this. Use it to check yourself. You can use it. I really just need to see your vertex and your graph. How you get that graph is up to you. Your vertex is found by looking at these two numbers, the inside and the outside at the back. The inside number needs to be the opposite, so if it says plus, put minus, and vice versa. Whatever is on the outside, you would put whatever it says. So you would plot that point, your vertex. This absolute value function does have a negative, so that means we are now reflecting it over the x-axis. It's now going to be facing down. But the slope has not changed. So we're going to go down one to the right one. We need at least 5 points, so if you stop here, that's fine. If you keep going, that's also fine. Questions on that one? And then your next one, your vertex for this, you're looking at the same places, this inside and this outside number, and doing the opposite for the inside, so that would be a -3, but keep the outside the same, -5. This is a quadratic function, so you have to either know what your quadratic looks like, or put it in your calculator and find those points. So you go right and left 1 and up 1, and right and left 2 from the vertex, and up 4. That was yes. Yes. Do you have any questions on that? You would go to your y equals. You're talking about the second one, right? Go into your y equals. Put in that function. So x plus 3 squared minus 5. And go into your table. And then find the points that would match. So start at your vertex and then go up from there. Mongo, with your question? Did the y do what every time? Not in this case. Because it didn't have a 2 out here. If it had a 2, then yes. So for the rest of the class, you will have this time to review, go back and look at any practice from any objective. I do have some of those extras, or they're in the crate if you need any of those. There's also, on the back of the last set of notes we were doing, the the Objective 5 notes, there is more review on the back of that, but that is just Objectives 3, 4, and 5, not 2 and 1. work on any of those. Let me know if you have any questions. Remember that tomorrow is your quiz, so make sure you get any questions you still have answered.